Dear students, welcome. This is our 7th class on vector calculus. Today, I shall try to solve these 8 problems. These problems will be the applications of vector identities. In the last 2 classes, I gave you some vector identities, and today I am going to apply these vector identities. First of all, I shall prove this one. Gradient of Fu equal to F dash U gradient of U. Proof of number 1. Proof number 1. Gradient of Fu equal to F dash U gradient of U. What is gradient of U? It is I cap delta U by delta X plus J cap delta U by delta Y plus K cap delta U by delta Z. Therefore, gradient of, we have proof number 1. We have gradient of Fu. This is equal to I cap delta delta X of Fu plus J cap delta delta Y of Fu plus K cap delta delta Z of Fu. You will get this one. This is equal to I cap. Differentiate this with respect to U. Then you will get F dash U. Now you will have to differentiate U with respect to X, partially delta U by delta X. Plus J cap F dash U delta U by delta Y plus K cap F dash U delta U by delta Z. This is equal to, you see, F dash U may be taken common from all the terms. I cap delta U by delta X plus J cap delta U by delta Y plus K cap delta U by delta Z. What is this? It is nothing but the gradient of U. This is nothing but gradient of U. F dash U, it is gradient of U. Thus, gradient of Fu equal to F dash U gradient of U. Gradient of Fu equal to F dash U gradient of U. Just remember this. You will have to remember this because this will also be applied later on. Gradient of Fu equal to F dash U gradient of U. Perhaps you have understood this. Therefore, we have proved number 1. Gradient of Fu equal to F dash U gradient of U. Number 1. Let me remove this one first. Let me remove this one. Now, see the second question. What is the second question? It is gradient of phi. You will have to find gradient of phi and its magnitude Gradient of phi and its magnitude. When phi equal to x square plus y square plus z square e to the power d. Let number 2, I am going to prove number 2 or solve the number 2 question. Let r square equal to x square plus y square plus z square. R square equal to x square plus y square plus z square. Therefore, phi equal to, it is given that x square plus y square plus z square e to the power minus x square plus y square plus z square whole to the power half. This is equal to r square e to the power minus r square. This whole to the power half r square e to the power minus r. Phi, this is equal to r square e to the power minus r. Thus, phi equal to r square e to the power minus r. Gradient of phi, the nebula phi, this it is nothing but gradient of phi. This is equal to gradient of r square e to the power minus r. Just apply this one. Apply the number 1. Gradient of Fu equal to F dash U gradient of U. Gradient of a function of r, it will be F dash U. This means d dr of r square e to the power minus r. ddr of r square e to the power minus r into gradient of r. This is equal to r square e to the power minus r. It is the product function. First function e to the r square minus e to the power minus r plus twice r e to the power minus r. It will be like this. What is gradient of r? Gradient of r equal to 1 by r vector. 1 by r vector. R square, this one, just differentiate this. Gradient of r, we have applied gradient of r. This is equal to I cap delta r by delta x plus j cap del r del y plus k cap del r del z. Get this one. Gradient of r means this. Now r square equal to x square plus y square plus z square. This means differentiate with respect to x partially. Differentiate with respect to x partially. You will get this one. This means del r del x equal to x by r. This will be equal to x by r. Del r by del x will be equal to x by r. You will get this one. Right? Similarly, del r del y equal to y by r and del r del z equal to z by r. You will get this one. Now gradient of r. Gradient of r. This is equal to I cap. For del r del x, you may put x by r. Put x by r plus j cap y by r plus k cap z by r. Just put this one. This is equal to 1 by r x I cap plus y j cap plus z k cap. This is equal to 1 by r vector. 1 by r vector. Just we have written this one. 1 by r vector. Now this is equal to thus this one. Why we have written gradient r is equal to 1 by r vector? The logic is this. Gradient phi equal to this one will be equal to e to the power minus r. Can be taken e to the power minus r. It will be 2 minus r vector. It will be like this. Because here this r will be cancelled. 1 r will be there. 1 r will be cancelled. 2 minus r. And the gradient of phi modulus will be equal to e to the power minus r. 2 minus r vector modulus. This is equal to e to the power minus r. 2 minus r, it is r. R vector equal to x I cap plus y j cap plus z k cap. The modulus will be equal to root of r x square plus y square plus z square. X square plus y square plus z square is equal to r square. Root of r square equal to r. It will be r. We have proved number 2 also. We have proved number 2. Now I am going to prove number 3. Just move it down. And perhaps you are understand. Now I am going to prove the number 3. What is this? The divergence of r to the power n r vector. The divergence of r to the power n r vector. Equal to n plus 3 r to the power n. This is equal to n plus 3 r to the power n. This one. Now number 3. Let me remind you, before going to prove the number 3, let me remind you one. We know that number 3. We know that This factor identity has been established in the previous class. Divergence of phi a factor, this is equal to, it is a vector quantity. You will have to find the divergence of a vector quantity. The result will be a scalar. Phi divergence of A plus gradient of phi dot A vector. Gradient of phi dot A vector. We know this one. Therefore, divergence of r to the power n r vector equal to r to the power n is phi. R vector for a vector here it is r vector. For phi this is r to the power n. R to the power n is equal to phi, right? R to the power n for phi. R to the power n divergence of r vector plus gradient of r to the power n. R to the power n dot r vector, you will get this one. Just I am going to mark it number. Now, divergence of r vector equal to, what is this? Delta x by delta x plus delta y by delta y plus delta z by delta z. You may write like this, because since if a vector equal to a1 I cap plus a2 j cap plus a3 k cap, then divergence of a vector equal to del a1 del x plus del a2 by del y plus del a3 by del z. Del a3 by del z. Now, here r vector equal to x I cap plus y j cap plus z cap. Here r vector equal to x I cap plus y j cap plus z k cap. Therefore, delta it will be 1 plus 1 plus 1 equal to 3. It will be equal to 3. Also, gradient of r to the power n, just apply number 1. Gradient of fu equal to f dash u, gradient of u. Gradient of r to the power n equal to the differentiation of r to the power n into gradient of r. Gradient of r. This is equal to n r to the power n minus 1. What is gradient of r? Gradient of r is nothing but 1 by r vector. Gradient r equal to I cap delta r by delta x plus j cap del r del y plus k cap del r del z. We have proved it for so many times. So many times it has been done. R square is equal to x square plus y square plus z square. This means twice r delta r by delta x equal to twice x. This means del r del x equal to x by r. Similarly, del r del y equal to y by r. Del r del z equal to z by r. Similarly, therefore, you will get this. Therefore, gradient of r equal to, gradient of r equal to I cap x by r plus j cap y by r plus k cap z by r. 1 by r, take it as common, it will be x I cap plus y j cap plus z k cap equal to 1 by r vector. 1 by r vector. Here, why we have written gradient r is equal to 1 by r vector? This is the explanation. This is the logic. 1 by r vector. This is equal to n r to the power n minus 2 r vector. You may write like this. Now we have found divergence r equal to 3. Gradient of r to the power n equal to this. Just put these two values in number 1. Therefore from 1 we get. Therefore from 1 you will get. You may write 1 implies. 1 implies this means from 1 we get. Divergence of r to the power n r vector. This is equal to r to the power n into 3. R to the power n into 3 plus this is the gradient n r to the power n minus 2 r vector, this dot r vector, right? Now from this you will get. This is equal to 3 r to the power n r to the power n minus 2 r dot r. You may write like this because what logic we have applied here? Since m a vector dot b vector equal to m a dot b, from vector algebra we have applied this one. We have applied this. M means a scalar. A vector is vector. This is a scalar. M a vector dot b equal to m can be taken outside and a vector dot b vector. This is equal to 3 r to the power n plus n r to the power n minus 2. It is nothing but r square. This is equal to 3 r to the power n plus n r to the power n r to the power n dr2. This is equal to 3 plus n r to the power n. Therefore divergence of r to the power n r vector, this is equal to 3 plus n r to the power n. We have proved the number 3 also. Perhaps you have understood this one. We have applied the vector identity, which is divergence of phi a vector. This is equal to phi divergence of a vector plus gradient of phi dot a vector. This theorem has been applied. This vector identity has been applied. Alright, now we are going to solve the number 4. Let me solve number 4. What is it? What is it? It is Laplace square r to the power n r vector. It is called Laplacian operator. Laplace square this is called Laplacian operator. You see, the Laplace square, this stands for del square, del x square, del square, del y square, del square, del z square. This also Laplace square f equal to del square, del x square, f del y square plus del square f del z square. Now, if it is a scalar quantity, Laplacian operator, it is a scalar quantity, then it will be again a scalar function. Also, if it is vector, then it will be a vector quantity. Then it will be a vector function. If it is scalar, if f is scalar, then Laplace square f is again scalar. If Laplace square f vector is a vector, then Laplace square f vector will be again a vector quantity. This one. Now you see, it is a vector quantity. It is a vector function. It is vector. Therefore, result will be again vector. The vector sign is there. Result will be again vector. Now, you see, if it is scalar, then the result will be a scalar. Now, you see, divergence of a vector quantity is always a scalar quantity, and divergence of a gradient of a scalar is a vector. Now you see, when you are going to find the lambda square a vector quantity, then you will have to write gradient of divergence of a vector. Finally, it is a vector quantity. Divergence of a vector is a scalar quantity. Gradient of that scalar quantity will be a vector quantity. Again, if you are going to find this one, then you will have to write divergence of gradient of phi. Divergence of gradient of phi. If it is scalar, you will have to write this one. If it is vector, you will have to apply this one. Now, Laplace square r to the power n r vector equal to this. We are going to prove this one. Now we are going to prove this one. Number 2. The Laplacian operator r to the power n r vector, it is nothing but gradient of divergence of r to the power n r vector. R to the power n r vector. Gradient of r to the power n r vector. R to the power n r vector. Now, divergence of, see the question number 3. Just as before, divergence of r to the power n r vector is equal to this. This is equal to gradient of n plus 3 r to the power n. Just as example number 3. Since divergence of r to the power n r equal to n plus 3 r to the power n. N plus 3 r to the power n. Prove it. You will have to prove this one. Just prove number 3 first. First prove number 3. Divergence of r to the power n r vector equal to this. R to the power n. Just apply the formula phi divergence of a plus gradient of phi dot a. Apply the formula, you will get this one. Now gradient of this equal to d dr of n plus 3 r to the power n. Gradient of r. Since gradient of fu equal to f dash u gradient of u. This has been applied. Gradient of fu equal to f dash u gradient of u. This is equal to n plus 3. N plus 3. N r to the power n minus 1. For this you will get this. For gradient of r, you will get 1 by r vector. Since gradient of r equal to 1 by r vector, it has been proved for many times in my class. I have already proved this. This is equal to n plus 3 n r to the power n minus 2 r vector. You will get this one. You will get this one. This. So, just we have proved this one. Number 4 has already also been proved. N plus 3 r to the power n minus 2 r vector. It has been proved. Now I am going to prove number 5. See the number 5. Perhaps you have understood this one. Let me remove this first one. What is question number 5? Question number 5 is also the same as the previous one. Divergence of R vector divided by R cube equal to 0. This is equal to 0. This is equal to 0. Now, number 5, we know the same will be applied here. Divergence of phi A vector. This is equal to phi divergence of A plus gradient of phi dot A. Therefore, divergence of R vector divided by R cube equal to divergence of 1 by R cube R vector. This is equal to 1 by R cube, it is phi divergence of R plus gradient of 1 by R cube dot R vector. This phi we have applied this. We have applied this theory, this vector identity. This is equal to 1 by R cube. What is divergence of R? Divergence of R vector equal to 3. It has already been proved. R vector is equal to xi cap plus yj cap plus zk cap. Therefore, divergence of R vector equal to delta x by delta x plus del y by del y plus del z by del z. This is equal to 1 plus 1 plus 1 equal to 3. This will be equal to 3. Plus, what is gradient of this? It is ddr of 1 by R cube gradient of R dot R vector. Gradient of fu equal to f dash u gradient u. This is equal to 3 divided by R cube. Plus, what is this? It will be minus 3 R to the power minus 4. Gradient of R means 1 by R vector dot R vector. It has been proved for many times. Gradient of R equal to 1 by R vector, and it is this is equal to 3 by R cube minus 3 by R to the power 5 R vector dot R vector dot R vector dot R. Now, what is this? This is equal to 3 by R to the power 3 minus, it can be written as 3 by R to the power 5 R dot R. What we have applied, since M A vector dot B equal to M A dot B, this has been applied here. This is equal to 3 divided by R cube minus 3 divided by R to the power 5. Magnitude of R factor is smaller, magnitude of this is smaller, into cos 0 means 1. This is equal to R square. This is equal to 3 by R cube minus 3 by R cube. This is equal to 0. This is equal to 0. Thus, divergence of R vector divided by R cube equal to 0. This means that if a vector A is, if divergence of A vector equal to 0, then the A vector is called solenoidal vector. Therefore, the vector R vector by R cube is solenoidal. Divergence of A vector equal to 0 means it will be solenoidal. We have proved this one. Question number 5 also has been done. When the divergence of a vector equal to 0, then the A vector is called this one, solenoidal. And if the curl of a vector is 0, then the vector is called irrotational. If curl A vector equal to 0 vector, then the vector A vector is called irrotational. Now, let me try to solve the number 5. Number 6. Prove that divergence of r cap equal to 2 by r. Divergence of r cap equal to 2 by r. Let me first remove this. Divergence of r cap equal to 2 by r. We know any vector equal to the magnitude of this vector into unit vector along the direction. This means the unit vector equal to r vector divided by r vector. This means r cap equal to r vector divided by r vector divided by r. Therefore, divergence of r cap equal to divergence of r vector by r equal to divergence of 1 by r vector. The same vector identity can be applied here. This is equal to 1 by r divergence of r vector plus gradient of 1 by r dot r vector. This is equal to 1 by r, it is nothing but 3. Divergence of r vector equal to 3. Plus, it is ddr of 1 by r, gradient of r, dot r vector. This is dot r vector. This is equal to 3 by r plus minus 1 r to the power minus 2. Gradient of fu equal to f dash u, gradient of u. It is nothing but 1 by r vector dot r vector. Right? Divergence of r vector is equal to 3 because if A is any vector, then if A vector equal to capital A1 I cap plus capital A2 j cap plus capital A3 k cap, then divergence of A vector will be equal to delta capital A1 by delta x plus delta A2 by delta y plus delta A3 by delta z. Here, since r vector is equal to x I cap plus y j cap plus z k cap, therefore divergence of r vector will be definitely delta x by delta x plus del x by del plus del y by del y plus del z by del z equal to 1 plus 1 plus 1 equal to 3. Equal to 3. This is equal to 3 by r minus r to the power minus 3 means 1 by r cube r vector dot r vector. This is equal to 3 by r minus 1 by r cube r vector dot r vector. Same formula has been applied. M a vector dot b vector. M is scalar, a vector and b vector are vector quantity. Then this is equal to m a dot b. M a dot b. This is equal to 3 by r minus 1 by r cube. It is r square. This is equal to 3 by r minus 1 by r equal to 2 by r. 3 by r minus 1 by r cube r vector dot r vector. This is equal to 3 by r minus. I am not confirmed whether the camera is covering this portion or not. Let me write the yeah. This is equal to 3 by r. This is equal to 3 by r minus 1 by r cube. 1 by r cube r square. This is equal to 3 by r minus 1 by r equal to 2 by r. This is equal to 2 by r. We have proved number 6 also. We have proved number 6. Now let me solve the number 7. Prove that the vector FR vector is irrotational. If it is irrotational, then we have to prove that curl of FR R vector equal to 0. We have to prove that curl of FR R vector equal to 0. Now, we know that number 7, we know that if curl A is equal to 0 vector, then the vector A is said to be irrotational. Therefore, we shall prove that curl of FR R vector equal to 0 vector. We shall prove this one equal to 0 vector. Why I have written a vector sign here 0 vector? Because curl of a vector function is a vector quantity. After all, it is a vector quantity. It will be of the form 0 a cap plus 0 j cap plus 0 k cap. Therefore, we have I have written the vector sign here. Curl of a vector quantity is always a vector quantity. Now, curl, we know that curl of phi A vector, this is equal to phi curl A vector, curl A plus gradient of phi, it will be a vector quantity, cross product of this, gradient of phi cross A vector, gradient of phi cross A. Now, therefore, curl of FR R vector will be equal to FR curl R vector plus gradient of FR this cross A vector, cross a R vector, for this is not for R vector. Or you may write, suppose this is number 1. What is curl R vector? We have already proved this. Curl R vector equal to 0. Curl R vector equal to, just write this determinant, I cap, j cap, k cap, del x, del y, del z, and it will be x, y, z. Because R vector equal to x I cap plus y j cap plus z k cap. This is equal to delta del z del y minus del y del z I cap plus del x by del z minus del z del x j cap plus del y del x minus del x del y k cap. This is equal to 0 a cap plus 0 j cap plus 0 k cap. This is equal to 0. This is equal to 0. Curl R vector equal to 0 vector. It will be 0 vector. No contribution from this term. Now, gradient of FR equal to F dash R gradient of R. F dash R gradient of R. Therefore, from 1 you will get. From 1 you will get. Therefore, 1 implies curl of FR R vector. Curl of FR R vector will be equal to FR, it will be 0 plus gradient of FR means FR, F dash R, gradient of R. This cross product R vector. This is equal to 0 vector. It will be 0, no contribution from this. Plus F dash R. What is gradient of R? gradient of r equal to 1 by r vector. Gradient of r means I cap delta r by delta x plus j cap delta r by delta y plus k cap delta r by delta j. What is delta r by delta x? R square is equal to x square plus y square plus z square. Differentiate it partially with respect to x. Then you will get twice r del r by del x equal to twice x plus 0 plus 0. Del r by del x is equal to x by r. Similarly, del r by del y is equal to y by r, del r by del z is equal to z by r. Therefore, gradient of r will be equal to I cap x by r plus j cap y by r plus k cap z by r. 1 by r can be taken common. 1 by r into x I cap plus y j cap plus z k cap. 1 by r vector. 1 by r vector. It will be nothing but 1 by r vector. Cross r vector. Since gradient of r equal to equal to 1 by r vector, it has been proved from many things. This is equal to f dash r 1 by r vector cross r vector. You may write like this. Since m a cross b equal to m a cross b, from vector algebra we have applied this one. This is m means scalar. A scalar vector, m a vector cross b vector. This is equal to m. Take m outside, it will be a vector cross b vector. Therefore, you may write like this. R vector cross r vector, the vector product of two equal vectors equal to 0 vector. This is equal to f dash r 1 by r 0 vector will be equal to 0 vector. Therefore, from 1 it will be 0. This is equal to 0 vector. Now, does it is again 0 vector. It is 0 vector. Does curl of fr r vector. This is equal to 0 vector. Therefore, the vector fr r vector is irrotational. It is irrotational. Therefore, it is irrotational. We have proved number 7 also. Number 7 has also been proved. Now, number 8, the Laplacian operator, which is nebula square, fr. Fr is a scalar quantity. The result will be a scalar. And if this is equal to 0, then we have to, this is the second part. First, let me prove the first part. Question number 8. Let me prove the first part first. Next, the second part will be proved later. What is this? The Laplacian of number 8. Nebula square fr. If it is scalar, result will be scalar. Nebula square fr will be again a scalar quantity. If it is vector, then the result will be vector. Here it is a vector quantity, result vector. If it is scalar, then compare with question number 4. If it is a vector quantity, the result is a vector quantity. And it is a scalar quantity, the result is a scalar quantity. Here, since it is scalar, you cannot find the divergence of a scalar. You can find divergence of a vector, but you can find the gradient of a scalar. Therefore, you will have to write dot this one, which is equal to divergence of gradient of apart. Divergence of gradient of f. It is yes, divergence of gradient of f. Divergence of gradient of f. This is equal to divergence of, you see, gradient of the scalar quantity will be vector quantity, divergence of this vector will be scalar, ultimately this will be scalar. Divergence of, it will be f dash r gradient of r. Apply number 1, apply this number 1. Gradient of f u equal to f dash u, gradient of u, gradient of u. We have applied this one. Divergence of this. This is equal to divergence of f dash r, gradient of r. It has been proved for many times. Gradient of r equal to 1 by r vector. Gradient r means I cap delta r by delta x plus j cap delta r by delta y plus k cap delta r by delta z. R square is equal to x square plus y square plus z square. Differentiate with respect to x partially. Twice r delta r by delta x equal to twice x. Del r by del x will be equal to x by r. Similarly, del r by del y equal to y by r. Del r by del z is equal to z by r. Therefore, gradient of r will be equal to I cap x by r plus j cap y by r plus k cap z by r. This is equal to 1 by r. In the bracket you should write x I cap plus y j cap plus z k cap, which is nothing but r vector. 1 by r vector. Now, it is what is divergence of a scalar and a vector. Scalar of a vector. This is equal to f into 1 by r into divergence of r vector plus gradient of this f dash r by r dot a r vector. We have since divergence of phi a vector equal to phi divergence of a vector plus gradient of phi dot a. Since this, we have applied this one. We have applied this one. We have applied this. Now, divergence of r vector is equal to, this is 3. This is 3 because divergence of r vector is equal to del r vector is equal to x I cap plus y j cap plus z k cap. Therefore, delta x by delta x plus del x y by del y plus del z by del z equal to 1 plus 1 plus 1 equal to 3. This is equal to 3, which is equal to f dash r by r into 3 plus gradient of, it is again a function of r, ddr of, you may write ddr of f dash r by r gradient of r dot r vector, dot r vector. You may write like this. A function of r, gradient of a function of r, this means that differentiate this function with respect to r into gradient of r. This is equal to 3 f dash r divided by r plus, what is this? It will be r square r, it will be f double dash r minus f dash r, and the r square differentiation denominator, differentiation of the numerator minus numerator, differentiation of the numerator. Gradient of r again 1 by r vector, again 1 by r vector dot r vector. Since gradient of r is equal to 1 by r vector. It has been proved many times, or many times. Plus, you may write here r cube r f double dash r minus f dash r R vector dot R vector. You may write like this. Same property has been applied. M A vector dot B vector equal to M A dot B. A dot B. This is scalar. This is scalar up to this. And it is vector M A vector dot B vector. M can be taken outside A vector dot B vector. This is equal to 3 F dash R by R plus it will be R cube R F double dash R minus F dash R. It will be R square. This will be R square. This is equal to 3 F dash R by R plus R F double dash R minus F dash R divided by R. R square R cube this will be cancelled. This is equal to R 3 F dash R plus R F double dash R minus F dash R minus F dash R. This is equal to 2 F dash R. This is equal to R F double dash R plus 2 times of F dash R divided by R, which is equal to F double dash R plus 2 by R F dash R plus 2 by R F dash R. Therefore, we have proved this one. Thus, the Nabla square Fr equal to this. Nabla square Fr is equal to this. F double dash R plus 2 by R F dash R. It has been proved. The second part, let me try to solve the second part. What is the second part? If Nabla square Fr equal to 0, then we have to show that Fr is equal to constant by R plus another constant, where R square is equal to X square plus Y plus V square. C1 and C2 are arbitrary constants. C1 and C2 are arbitrary constants. Second part, Nabla square Fr equal to 0. This is given. This means we have proved that this is equal to F double dash R plus 2 by R F dash R equal to 0. This will be equal to 0. This means that F double dash R equal to minus 2 by R F dash R. It will be like this. This means F double dash R divided by F dash R equal to minus 2 by R. Now integrating with respect to R. With respect to R. Now integrating with respect to R. Integrate F double dash R by F dash R will be equal to integration minus 2 by R constant of integration dr with respect to R dr. This means log of F dash R equal to minus 2 log R minus 2 log R. Write it not C, log C plus log C. The constant of integration, where log C is the constant of integration. This will be equal to log of F dash R equal to log of C by R square. This means F dash R equal to C by R square. equal to C by R square. Again integrating with respect to R. F dash R dr equal to integral C by R square dr plus C2. Suppose this is C2. But not C2, suppose write this C dash. C dash. This implies that it is equal to dr of Fr, it will be equal to definitely Fr equal to C R to the power minus 1 by minus 1 plus C dash. This means Fr equal to minus C by R plus C dash. C by R plus C dash. Or you may write, or Fr equal to C1 by R plus C2, where C1 equal to minus C. C dash is equal to C2. We have to prove this one. Fr is equal to replace minus C by another constant C1. Therefore, the second part has also been proved. We have proved the second part also. We have in total solved 8 problems today. Some applications of vector identities. In the next class, we shall try to solve some more problems. For today, I want to stop here. Thanks for attending the class. Thank you very much. Thank you.